students, this is day 2 of chapter Electricity and Magnetism, and specific objectives for today's class are electromagnetism, electromagnets and their applications, and electric bell. In previous class, we have discussed topic number 7.1, properties of magnets, and 7.2, test of a magnet by repulsion. And today we will learn topic number 7.3, electromagnetism, and 7.4, that is electric bell. Students, let us first understand the meaning of electromagnetism. It is a process in which magnetic field is created by introducing current in the conductor. Do you know that magnets can be made by using electric current? Isn't it interesting? Our next topic is electromagnet. Let us learn about electromagnets. An electromagnet is a type of magnet whose magnetic field is produced by the flow of electric current. Let us perform an activity to understand the behavior of electromagnet. Take around 75 cm long piece of insulated flexible wire, 6 to 10 cm long iron nail, a cell, a switch, a bulb, and few pins. Now wind the wire tightly around the nail in the form of a coil as shown in the figure. Connect the free ends of the wire to the terminals of the cell through a switch. Place some pins near the end of the nail. Now switch on the current. Do the pins cling to the tip of the nail? Yes, you can clearly see the pins clinging to the nail. Now switch off the current. Are the pins still clinging to the nail? No, the pins now do not cling to the nail. Let us understand the reason behind this phenomenon. The coil behaves like a magnet when current flows through the coil. So when the current is passed through the coil, the magnetic field so produced orients pins according to magnetic field. The magnetic field disappears when the current ceases because coil generally loses its magnetism, and hence in absence of magnetic field, the pins retain their original position. Such coils are called electromagnets. Electromagnets find many applications in different fields because of their remarkable property. The strength of their magnetic field can be increased by increasing the current in the coil and by increasing the number of turns in the coil. Electromagnets can be of varying shapes and sizes depending on their uses. You would have seen cranes which are used to lift cars. The ends of such cranes have strong electromagnet attached to them. These cranes are used for lifting heavy load. Electromagnets are widely used as components of other electronic devices such as motors, generators, loudspeakers, hard disk, MRI machines, as well as they are also used in industries for picking up and moving heavy iron objects like scrap iron. Doctors also use tiny electromagnets to take out small pieces of iron that are accidentally fallen into the eye. Many toys also have electromagnets inside them. Electromagnets are also used in electromagnetic trains called maglevs. Students, let us summarize the topic electromagnet. An electromagnet is a coil of an insulated wire wrapped around soft iron core that behaves as magnet when current is passed through it, as shown in diagram here. It is a coil of insulated wire wrapped around soft iron core. Here, iron nail is used, right? And it behaves as magnet only when current is passed through it. Strength of an electromagnet depends upon amount of current passing through the coil, and number of turns in its coil. If we increase the amount of current passing through the coil, strength of electromagnet will increase. And by increasing number of turns in its coil, we can increase the strength of electromagnet. Next topic is choice of material for the core of an electromagnet. This topic is not given on your book, so you need to note it down. The core of an electromagnet, that is the central part of electromagnet, must be made of soft iron. This is because it loses all its magnetism when current in the coil is switched off. Because soft iron is a soft magnetic substance, so it loses its magnetism when the current in the coil is switched off. Why steel is not used as a core of an electromagnet? Because when a steel bar is used in place of soft iron core, it changes into a permanent magnet. So steel is not used for making electromagnets. We know that steel is a hard magnetic substance. It does not lose its magnetism even if the external magnetic field is removed. So that is why steel is not used for the core of an electromagnet. Let us discuss various uses of electromagnets. Electromagnets are used in electrical appliances such as electric fans, electric motors, loudspeakers and electric trains. Electromagnets are also used in cranes for lifting and transporting heavy loads like cars, big machines and steel girders. They are also used by doctors to remove tiny iron particles from the eyes that are fallen accidentally. And they are also used in MRI machines. What are MRI machines? MRI means magnetic resonance imaging. Such machines use magnetic field produced by electromagnets to take pictures of internal organs in order to detect any type of disease. Right? Students, let us read from the book for better understanding. Electromagnets. An electromagnet is a coil of wire wound around soft iron core. This is the definition of electromagnet, or simply you can write the substance that behaves as a magnet when current is passed through it is called electromagnet. When current is passed through it, it behaves as permanent magnet except that it can be turned off. So basically it is a temporary magnet because its magnetism can be switched on and off. It usually contains a soft iron core. The purpose of core is to increase the intensity of magnetic field. Students, soft iron core is used, but steel cannot be used. Why? Because if we use steel as the core of an electromagnet, it will not lose its magnetism even when the current is switched off. So it is preferred to use soft iron core. Electromagnets are made into different shapes. Two of the well-known shapes are I-shaped or a straight electromagnet and U-shaped or horseshoe type electromagnet. Let's learn about them. I-shaped or straight electromagnet. An I-shaped electromagnet is made by winding a large number of turns of insulated copper wire over a soft iron core. So basically an insulated copper wire is wound around a straight iron bar, or we can say soft iron bar, like this. And the free ends of the wire are connected to the terminals of a battery. When current is switched on, it will pass through the coil and it will behave like an electromagnet. Students, they have written source of EMF. What is EMF? EMF means electromotive force. It is a kind of energy that pushes the positive charges from positive to negative terminal of the battery. Figure 7.4 shows an I-shaped electromagnet. It is given here. When current is passed through the electromagnet, the magnetic field is produced around the coil. Since the coil is a solenoid, students, solenoid is a cylindrical coil of a conducting wire. Therefore, magnetic field is restricted at the center of the coil. This magnetic field magnetizes the soft iron bar, which then begins to behave as a magnet and begins to attract magnetic material towards itself. Strength of magnetic field of an electromagnet. The strength of an electromagnet is the strength of magnetic field it can create near its poles. It depends upon the factors given here. Number 1, strength of electric current. Number 2, number of turns of the wire in the electromagnet. And number 3, material of the core on which the wire of the electromagnet is wound. So we can say that strength of an electromagnet can be increased by increasing the amount of current, by increasing the number of turns of the wire, and by choosing a material for the core which has high permeability. It is given here also. Students, the word permeability means ability of a material to attract and conduct magnetic lines of force. This we will discuss in higher classes in detail. Simply you need to know that materials whose permeability is high, that have more ability to conduct magnetic lines of force, they are magnetized to a great extent. Students, let us now learn about an application of electromagnets, that is electric bell. First we will learn about its construction, then we will also learn about its working.
The main components are first a horseshoe electromagnet having a soft iron core. Why it is made up of soft iron core? Because it loses and gains magnetism easily as compared to any other material. Second, a soft iron armature. This is the armature. It is also made up of soft iron. Third, a hammer edge. Hammer edge is at one end of the armature, which strikes with the gong and produces the sound. A metallic strip SS, an adjusting screw which is used to make adjustments, a switch and a battery. Students, let's see how an electric bell works. When we on the switch, current flows through the coil and an iron core gets magnetized. It attracts the armature towards it, and the hammer which is attached with the armature strikes with the gong and sound is produced. But notice, when the hammer strikes with the gong, the connection between this strip and the screw breaks. When it breaks, the current stops flowing, but the hammer pulled back to its original position, and then it again completes the circuit. When circuit is completed, current flows through the coil again and hammer strikes again, and you hear the ringing sound as long as switch is pressed. In this way, we hear the sound.
Students, let us read from the book for better understanding. Electric bell. An electric bell is a common electrical gadget used in homes and offices. You might have seen also. Construction and its wiring and working as well. An electric bell consists of the following parts. First, electromagnet. Students, it is a horseshoe magnet which gets magnetized when the switch is pushed. Soft iron armature. It is a soft iron metal piece to which hammer is connected. It is shown here. This is known as soft iron armature, and to this armature hammer is connected. When electromagnet gets magnetized, so when this electromagnet will behave like a magnet, what will happen? It will attract this soft iron armature. And what will happen? The hammer will strike the gong and sound will be produced. Next is springy metal strip. The springy metal strip acts like a spring and is useful in making and breaking the contacts. It is shown here in the diagram. This is the springy metal strip. Students, how it helps in making and breaking the contact? When the current is switched off, when the electromagnet no longer behaves as a magnet, then what happens? This spring-like metal strip will pull the armature back to its original position and the connection will be made again. Next is hammer. It is a small metallic sphere which strikes the gong to produce sound. You can see here in the diagram. Next is gong. The gong is a metallic hemisphere which is struck by the hammer to produce sound. This is gong. Next component is contact screw. It is a screw used to adjust the contact between the metal strip and the mains or main supply, that is battery. Contact with it makes or breaks the circuit. It is shown here at point C. This is contact screw. When there is contact between the contact screw and the springy metal strip, it means the circuit is complete and the current will flow through the circuit. But if there is no contact at point C, it means circuit is incomplete. There will be no flow of current. Let's read its working now. When the circuit shown in the diagram is completed, or we can say when the current is switched on, the current flows in the coil of the electromagnet, which becomes magnetized and hence attracts the soft iron armature towards itself. As a result, what will happen? The hammer will hit the gong and the bell rings. As the hammer hits the gong, the circuit at point C becomes incomplete, or we can say the contact at point C is broken and the springy metal strip loses contact with the contact screw. The electromagnet loses its magnetism and no longer can attract the soft iron armature because there is no current flowing in the circuit. The springy metal strip is then able to pull the armature back. Why? Because this is like a spring, it has elasticity, so it can pull the armature back to its original position. And as a result, it will remake the contact at point C and hence completing the circuit again. When the circuit is completed, current will start flowing through the circuit and it will result in magnetization of the electromagnet, which will behave like a magnet and will attract the soft iron armature towards itself, resulting in striking of the hammer with the gong and it will produce sound. As a result, the contact will be broken again and this process is repeated so long the bell push or switch is pressed and continuous ringing occurs. Students, you must be able to answer all these questions. Define an electromagnet. Write down various uses of an electromagnet. Why is an electromagnet called a temporary magnet? How can you change the strength of an electromagnet? What is the basic principle of an electric bell? And draw a neat and clean diagram of an electric bell. And last question is, what is the full form of EMF? Note down all these questions and revise them properly. Thank you.